answer some of the questions that are down below on page 38. So on your page of graph paper that you have, when we graph tangent, we generally think about, why that's not all showing, oh well. We generally actually think about the asymptotes because the graph kind of is based around the asymptotes. So when you have a tangent graph, if you look at your graph, come on, buddy. There we go. Where are the asymptotes located on the graph that you have on page 38? Brandon.
Negative 3 pi over 2.
Okay, so he said negative 3 pi over 2. Brandon, is there any other asymptotes?
Negative pi over 2, and then it's positive in pictures. Pi over 2 and 3 pi.
Yeah. So you could summarize that by saying, I'll put this guy next to it. All of the pi over 2 values have an asymptote for tangent. So if it's a pi over 2 value, there would be an asymptote for the tangent function. Any pi over 2 value. So if we continued 5 pi over 2 to 7 pi over 2, 21 pi over 2, 51 pi over 2, 57 pi over 2, whatever number you happen to like, there would be an asymptote for the tangent. So that's kind of something that we're going to think about. Now the whole reason why, because I want you to think, why is there an asymptote? Why does it happen? So going back to the unit circle, that lovely unit circle, we have the angle of 0, pi over 2, pi, 3 pi over 2. You don't have to draw this. This is just kind of an explanation so you physically see why this is happening. At the angle of 0, what's the ordered pair? Chelsea?
0, 0. Or 0, 1.
0, 1. Chelsea, at pi over 2, the angle is
1, 0.
1, 0. And then at pi,
0,
how about,
1.
I think you
1,
have them
0.
flipped.
Yeah, I do.
Yeah.
I just realized that.
I did too. Okay, so this is 1, 0, negative 1, 0, 0, 1, and then finally 0, negative 1. There we go. So why is tangent undefined at 3 pi over 2 or at pi over 2, Brandon?
Because tangent is y over x, and anything divided by 0 is undefined.
Exactly. So the tangent function is y over x. And because at pi over 2 and at 3 pi over 2, you have 1 divided by 0 or negative 1 divided by 0, that's why it's undefined. Anything that's undefined creates an asymptote in your graph, which is why the graph has asymptotes. So if you continue to spin around the unit circle and get the 5 pi over 2 or the 7 pi over 2 or the 11 pi over 2, anytime you hit that location on the unit circle, the 90-degree angle, the 270-degree angle, you're always going to have an asymptote. So when we graph it, we're going to focus on the asymptotes because that really does help create the graph. The other thing we're going to look at would be the x-intercepts. So if you look at your graph, where are the x-intercepts on the tangent graph? Nick, where do you have an x-intercept at the tangent graph?
0, 0.
Yeah, so there's an x-intercept at 0, 0. And that's because at the angle 0, y is 0, x is 1, well 0 divided by 1 equals 0. Nick, is there another one?
Yes.
What other angle?
Pi.
Yeah, at pi or at negative pi. Those also would be values because at pi, 0 divided by negative 1 is 0. Or at negative pi, you'd still have 0 divided by 1, or 0 divided by negative 1, which is which is 0. So the x-intercepts are in between the asymptotes, and that's because just off those 4 angles in the unit circle, your asymptotes are the vertical values, the horizontal values are the x-intercepts. Well, they're in between the 90 and the 180 degrees. The 0 would be in between 90, 180 is also in between the values. So now we're going to make a little sketch, and then we're going to see if we can make sure we answer the other questions down below about the period and the amplitude. So we're going to label this just like we did before, go over 3 spots, call that pi over 2. Because we're still counting by pi over 2 if that's where our asymptotes are. So we'll label that as pi over 2. 3 more is pi. 3 pi over 2. And we're not going to go to 2 pi because then we'd have like half of a graph. And So that's why it just has you stopping at 3 pi over 2. So the first thing we're going to graph is asymptotes. And Brandon, when you graph an asymptote, what does it look like?
A dotted line.
A dotted line. So we're going to make a dotted line at the pi over 2 values. So 3 pi over 2. So the graph should start with an asymptote on the left and with an asymptote on the left. That way we have 3 whole graphs instead of having like half or one. And then in between these would be the x-intercepts that Nick gave us. So 0, pi, and negative pi. Just because we're changing the graph, we're not making sine or cosine, doesn't mean that things aren't still equally divided. So in between two asymptotes, directly in between is always an x-intercept. Now we need to make sure we have a couple other points, and we're going to still have 5 values that we think about, but they're not all points. So we still need to get a point in between the x-intercept and the asymptote so that we know how high this graph stretches. And that would be using the angle that's directly in between 0 and 90 degrees, or 0 and pi over 2. Libby, what angle would be in between 0 and pi over 2? Directly in the middle of 0 and pi over 2.
So the 90. Or
What's between 0 and 90 degrees?
Oh, would it be pi over 3, pi over 4, pi over
Yeah,
6?
and I want the pi over 4 one because that one's the one that's smack dab in the middle. So in the middle of 0 and pi over 2 is pi over 4. And the reason we want that one is because the tangent of pi over 4 is what? What is the tangent of pi over 4? Anyone know what the ordered pair of pi over 4 is? There it is. Chelsea?
it'd be 1.
Yeah, it'd be 1. Because of pi over 4, our ordered pair is the square root of 2 over 2, square root of 2 over 2. So that's a really nice angle to use when you're talking about tangent, because when you take y divided by x, you get the value of 1. So I'm just going to put a little tick mark in right smack dab in the middle of 0 and pi over 2, because halfway in the middle is pi over 4. And we are going to go up 4 and call that 1 and put a point. So now we have a point that we can then start to connect our x-intercept with. The other point is on the other side of 0, so in between 0 and negative pi over 4. Well, in between 0, and negative pi over 2 would be negative pi over 4. That has the ordered pair of the square root of 2 over 2 and negative square root of 2 over 2. So that means tangent y divided by x isn't going to be positive 1, but instead it's going to be negative 1. So when you connect them, it does make a curve. It kind of makes like it's a very thin curve. It's not very steep. But starting at the left, skimming along the asymptotes, it then curves to your point, and then it skims along the asymptotes. That one looks sloppy. I'll try another one and make it a little nicer. See if I can get this one to be a little better. Start here. That's a little better. So it's supposed to connect with that point and then kind of like skim on next to the asymptotes, because it's just going to continue just to go vertically forever. So it doesn't stretch wide, it just stops at the asymptote and then skips vertically next to it. So we'll graph 3 of them. So the third one would have the same as the other 2. Once you have one graph, the other 2 are exactly identical. They should mimic each other. These graphs repeat. There's repetition to them. Once you have one done, it kind of just continues. You can graph as many as you need to. You'll be asked to graph 2 full periods. So the other questions, I think one of them was the domain. So the domain, I think that was the first question. If you're starting at like -3 pi over 2 to -pi over 2 with parentheses, and then you would have -pi over 2 to +pi over 2 with parentheses, and then you would have pi over 2 to 3 pi over 2. So the domain goes with the asymptotes. Whatever the asymptote is, you should have parentheses. So in this drawing, you would have 3 pieces to the domain. Doesn't want to be my friend today. Here we go. So our domain, just with what we have here, to kind of make sure you have your question answered, you'd have parentheses around the asymptote values. So that would be the domain of the graph. Now we continue, depending on how far you have it graphed. What's the range? Oh, Libby question.
Wouldn't you put the U's?
Yeah,
Okay,
thanks.
that's just.
Nope.
Sorry.
You're good. You know what the range is, Libby?
The range is negative infinity to infinity.
Yeah, negative infinity to infinity. So the other 2 questions that I think are down below, I think it talks about the amplitude and the period. I don't know which is which. I don't have mine open. Anybody take a shot at what you said the amplitude was? Virginia?
The amplitude be 1
Why would you say 1?
because it's like halfway in between.
Okay, so, and we do use the value of 1 because you're stretching up to that point. But what is the actual definition of the amplitude?
Would be infinity then.
It would be infinity. Yeah, amplitude is the vertical stretch, how high it stretches. So the amplitude technically stretches to infinity and negative infinity, but because infinity is not really a number, we actually say none. So yes, it goes to infinity. The vertical stretch of the graph is to infinity, but infinity really isn't a number. So it doesn't really have a true amplitude. So the amplitude is actually none. And then the last question is the period. Anybody want to take a shot at that? Chelsea, what'd you have?
Pi.
Why'd you say pi?
Because each graph stretches from -3 pi over 2 to -pi over 2.
Yeah. So looking at those asymptotes, that's the distance of a period. Once your graph repeats, once you see the repetition, then you have a second period graph. So the period for tangent is only pi. We actually have 3 repetitions up here. But it's from one asymptote to the next, and that distance in between those is just the distance of pi. Questions? So when we graph tangent, we're going to focus on the asymptotes and how those asymptotes change, how they shift left and right, how they stretch left and right. So we'll be focusing just on the asymptotes and then trying to get the rest of the graph from the asymptotes drawn, because everything then is directly cut in the middle, and then in the middle the x-intercept, in the middle of the asymptote. So if you now switch to the next page, just move your little graph over and look at your cotangent graph. We're going to do exactly the same thing for cotangent. So if you look at your cotangent graph, I want you to make a nice clean one, like this. So where are the asymptotes for cotangent? Alice, do you have an asymptote for cotangent?
So 0.
Yeah, there's one at 0, because cotangent is now what over what, Alice?
It's x over 1.
Yeah, it's x over y. So since it's x over y, my x is 1, the y is 0, so now I have 1 over 0. So that would be one location. Where's another asymptote, Alice?
Pi.
At pi. And how about one more?
Negative.
At negative pi. Notice the x-intercepts that we had for tangent are now asymptotes for cotangent. And that's because they're reciprocal functions. So if you have an x-intercept, now it's an asymptote because 1 over a value of 0, where the x-intercept was, now is undefined. And then finally, getting the x-intercepts for cotangent. Using that same kind of thought process, if there's an asymptote, now it's an x-intercept because they're reciprocals. They're They're opposites. So we only have to go from negative pi to positive pi. So we would have an x-intercept now at negative pi over 2. We would have an x-intercept at positive pi over 2. So they are opposite reciprocal functions. So where there's an x-intercept for the one, you have an asymptote for the other. So graph it the same exact way. Make yourself a nice graph. So we're going to go over 3. We only need to go to pi and negative pi. So over 3 is pi over 2, and then we have pi. So graphing the asymptotes first, they are now at 0, so we have an asymptote right down on the y-axis, at pi, and at negative pi. Now we only have 2 graphs shown here. So 2 sets of asymptotes will get 2 graphs. In between those would be our x-intercepts at pi over 2 and negative pi over 2. And then we're going to count up 4 again and call that 1, go down 4, call that negative 1. So when you make your graph, in between 0 and pi over 2 is the angle pi over 4. The tangent was 1, well the cotangent is 1 over 1, so that's still 1. So in between 0 and pi over 2, we still have a point at 1. If you go in between your next angle, in between pi over 2 and pi, well that's the second quadrant, that's 3 pi over 4, and tangent is negative in the second quadrant, so that angle would go down to negative 1. So now I have really 5 pieces. I've got 2 asymptotes and 3 points. When you connect them, this graph does the opposite of tangent. It goes down where tangent goes up. So tangent is increasing, cotangent is decreasing. They're reciprocal functions. So when you make your second one, make it look like a repeat of the first. So it should go down instead of going up. So this domain would be from negative pi to 0, and then from 0 to pi. And I know you graphed yours to 2 pi, so you would have negative 2 pi to negative pi, positive pi to positive 2 pi. The range is still the same, negative infinity to infinity. So what do you think the amplitude is for cotangent? None. If tangent doesn't have any amplitude and cotangent looks almost the same, it's not going to have an amplitude as well. Brandon, how about the period? Just pi, yeah. Again, the distance from one asymptote to the next is your period, and that's just pi. Questions on that information that was underneath those 2 graphs? So if you want to flip to the next page of your packet, you can. But I'm going to do the example that is at the very bottom of the page 40. I think it's the bottom of page 40. Nope, bottom of page 41. But if you'd like to graph in there, you can. Feel free to use the graph paper that I handed out to you. Just that graph is so, the grid is so faint. So I'm going to do that problem down there. We're going to work through that problem so you can see how to graph a tangent and a cotangent graph. Tomorrow we'll talk about the secant and cosecant. But we're going to see if we can kind of talk about the tangent graphs. So it has at the bottom start finish. You really don't need to worry about the start finish. But we're going to still think about what those values mean. So a standard equation still looks like A, but now it has the word tangent in it. Bx minus c and then plus d. So that equation is the same for every trig function. You change the function, but the letters stay the same. So the function changes the graph, but the letters affect the graph in the same exact way. So Virginia, what would the A value be?
Would be the
So what number is that? What number would be A in this problem? -3, yeah. So the A is -3. The B is 2. So there is no amplitude, even though we have a -3 there. I'll show you how that affects the graph, but it's not the amplitude, still none. What would the period of this graph be? How would you find that? So what's the regular period? Michael?
It'd be pi over 2.
Yeah. So it's usually pi over b. Well, that's pi over 2 now. So instead of 2 pi, it's now pi. It's half because we're talking about tangent. Is there a c value? No, there's no parentheses, so there's no c. And there's no d. D is whatever's being added or subtracted after the function. So to graph this, I said we're going to focus just on the asymptotes. And that's what we're going to calculate. So you're not necessarily going to have 5 key points. You're going to just have the asymptote values. And then we're going to kind of just make sure we graph the rest of it based off the asymptotes. We're taking the bx minus c part, whatever is after the tangent. And we're going to set that equal to where the original asymptotes are supposed to be for tangent. And that's all the pi over 2 values. So pi over 2 and negative pi over 2. You could also set it equal to 3 pi over 2 or negative 3 pi over 2. So these are the original asymptotes for tangent. So in this problem, there's a 2x. That's what's after tangent. So we're going to take that 2x and set it equal to pi over 2. Because that's going to give me then my new asymptote location. Because that's what's going to change here. Whatever affects x has to affect the asymptotes because that's your x value. So my new asymptote, what's 2x equals pi over 2? What's, if I solve for x, what would x be equal to? Libby?
It would be pi. Or, no, it would, no. It would be pi over 4.
There you go, pi over 4. So that's going to be our new asymptote. Instead of it being at pi over 2, because the period is different, the new asymptote is at pi over 4. And then the second one, take the 2x, set it equal to negative pi over 2. So then another one would be equal to negative pi over 4. So we're going to count by pi over 4. So I'm still going to go over 3 spots, but I'm now going to call that pi over 4. Go over 3 more, that's going to be pi over 2 because it's 2 pi over 4. 3 more would be 3 pi over 4. So this graph won't necessarily look any different from the first graph that we drew for tangent, but the bottom's labeled a little differently. And then we'll just go up 3 and call that one so we can fit it on the graph because it has a 3 in front. So 3 boxes I'm using to represent 1, the value of 1. So starting with the asymptotes, we have 1 pi over 4. That's where our new asymptote is. We have an asymptote of negative pi over 4. Where would another asymptote be located, even though we didn't find it? Brandon?
Pi over 2.
Not pi over 2. Right, negative 3 pi over 4. Because it has to skip a point because in the middle we have to have an x-intercept. And then positive 3 pi over 4. So we always need an x-intercept in the middle of our asymptotes. Okay, so now plot 2 x-intercepts. Actually, I guess 3 here. So an x-intercept, an x-intercept, an x-intercept. Again, all we're finding is the asymptotes. The middle of the asymptotes has to be an x-intercept. And then the last thing we need would be 2 points on either side of the x-intercept so that it's directly in the middle of an x-intercept and an asymptote. And that's where the -3 comes in. So if I go back to the graph that we have for tangent, here. So here's our tangent graph. The point in between 0 and pi over 2 was up at 1. But that point now is being multiplied by -3 because A multiplies your y values by -3. So this point right here is going to go down now to -3 because it was at +1, but if I multiply that by 3, it's now at -1. So that would be that A value giving us a vertical stretch, but it's also reflecting the graph. So in between, we now have it down at -3. On the left side of the x-axis, that one is up at +3. So they're flipping because of the negative value. So when you connect them, try and connect that point with your x-intercept. Questions? So what does this graph look like? A cotangent graph. So a negative tangent graph looks like a cotangent graph. The asymptotes are just different. So when we go to write equations on Friday, we'll be able to write 2 equations just like we did with sine and cosine. We'll be able to write 2 equations for tangent and cotangent. So if cotangent's positive, then your tangent's negative. Or if tangent's positive, then your cotangent will be negative when we go to write those graphs. Questions? So we're going to do one other problem. And it's at the top of the next page. Again, if you want to follow along the notes, you can, or you can graph on the graph paper. But I want to make sure you can graph both tangent and cotangent. Same equation, just tangent is now cotangent. And we're going to start with that same information. So A is the number in front, that's the 2. What number is B? Chelsea? 1/3. So when we go to find our period, we're taking pi over 1/3. Which really is 3 pi. So now the distance between the 2 asymptotes is going to be 3 pi. C and D are still 0 because there's no parentheses. So it can't be a C. There's not a number being added outside. If there were, that would just change that center of the graph and shift it up. So like the x-axis just gets shifted up or down. So we're going to take bx minus c and set it equal to where a cotangent function has an asymptote. Grace, where does a cotangent function have an asymptote? Yeah, at pi and negative pi. And it also has one at 0, so we might as well make sure we find that one too. That one's easy to get. So tangent is pi over 2. Cotangent would be the multiples of pi. Taking whatever's after the cotangent, in this case it's just x over 3. And that's what we're using to get our asymptotes. So x over 3 equals pi, x over 3 is equal to 0, or negative pi. So I still have one at 0 because it's not shifting. There's no phase shift in the problem. And then we have one at 3 pi, and one at negative 3 pi. So what do you think you could count by? Hi, pi. I mean, we got 3 pi. So I'm just going to go over 2 boxes and call that pi. Another 2, call that 2 pi. Another 2, call that 3 pi. But makes sense to probably count by pi's since you've got that as an increment. And then graph those asymptotes. So directly in the middle is your intercept. So go to the middle, graph your intercept. And then you're going in the middle of your intercept and the asymptote. This is cotangent. So cotangent is a decreasing function. So that means when you go to the middle on the left side, we're going up to 2. In the middle on the right side, we're going down to negative 2. So cotangent decreases, tangent increases. So in between the asymptote and the intercept on the left, it starts high and it ends low. And that 2 value is the only thing that you're using to get that second point. Questions? So the homework tonight, again, it's what's on the board. I also did send a correction through Remind, but I'll print out a second assignment sheet for tomorrow. That's for tomorrow and next week. So we've got 6 graphs. They're all tangent and cotangent. Some of them have a phase shift. Whatever that phase shift is, you're working with the asymptote values. So the initial asymptote values is where you're going to go up. Anybody interested in doing 13 or 45 for tomorrow? So tomorrow, yeah, 13. Sure. Tomorrow we'll go over secant and cosecant, which is really just graphing sine and cosine. And then we'll kind of just make sure we refresh on the